this session, we also have our moderator, Benaya Simeon. Hi, Mbak Naya.
Good morning, good afternoon, and good evening for me. Everybody. I'm Naya. Nice to meet you all.
Hi, Naya.
Yeah, so Mbak Naya is currently pursuing her PhD at Charles Darwin University, ya, Mbak, and her research focus a lot on sharks, and she also has been helping IDSSG in many ways, including facilitating our communication with the Ministry of Marine Affairs and Fisheries. So with that, I would now like to hand the session over to you, Mbak Naya.
Thank you so much. Let me make a small introduction about myself. My name is Naya. So I'm doing my PhD in Charles Darwin University, and I've been working on sharks in last 10 years. And I also the part of shark specialist group, like IUCN Global Shark Specialist Group. And yeah, like mostly we are really familiar, like what Celia mentioned, we're really familiar with red list assessment, but how about the green list? Like how optimistic we are as Indonesian with all of the extinction rates that we have, all of the habitat loss. And meanwhile, we also the main hotspot for biodiversity in Indo-Pacific between Asia, Wales line, and Australia. So yeah, it's like kind of interested to learn about green list, status, and yeah. That's like short introduction from me, and let me introduce two of our speakers' biography. Like I also got it from Celia and Tim, so I will read it. For our speakers, first is like Magdalena Sigen, Sigen.
Sigan, yes.
Sigan, okay, Magdalena Sigan. She is a conservationist biologist who dedicated and advancing in IUCN green status of species, which measures species recovery and conservation impact. At IUCN, our speaker coordinates a global expert network, deliver training, and support evidence-based conservation policy and practice, with a background in rangering, ecological survey, and research, especially in African elephant and Madagascar plover. How cute. Magdalena Sigan also developed a strong expertise in field ecology, like GIS and scientific writing, holding the first class degree in biology and biodiversity conservation. She also explored wildlife through art, illustration, and poetry, aiming to bridge science and creative for impactful conservation. It's really amazing for having her with us this afternoon and this morning for her. And then we also welcome for our another speaker. I will introduce Molly also. Molly K. Grace is a conservation scientist and educator specializing in species recovery and biodiversity metrics. And she also a co-chair of IUCN Green Status of Species Working Group and department lecturer at University of Oxford School of Geography and Environment, where she also directs the BCNR course, Biodiversity, Conservation, and Nature Resource Management. Her career span roles as senior research lead at Accounting for Nature and Research Fellowship in Biology, Conservation, and Oxford, with her focus on species recovery, conservation success, and human-wildlife interaction. It's such an honor to have both of our speaker here with us. And like what I've mentioned in Indonesia, we looking for this, optimism about the green list, because like considering our biodiversity, our threat, and then the condition in our country is like excited to see not only red list, but also the hope for the species through green list, green status. Okay, so let me pass it to the first speaker. Who's the first speaker, Celia? Sorry, I'm lost.
Okay. No
It's
worries.
Molly? Okay.
Yes.
Yeah, it's Molly.
Okay, Molly, like time and place is yours.
Thank you so much, Naya and Celia, and thank you to everyone for being here. It's so wonderful to see so many people interested in learning about the IUCN green status of species. As Naya mentioned, I am the co-chair of the Green Status of Species Working Group based in Oxford. The other co-chair is Dr. Barney Long, who many of you may know, based in the US. And really today, I'm going to be talking just very briefly about some of the history of the green status, and then I'll pass over to Magda for most of the session. But I'm just here to help set the scene. Just a quick question. Hopefully everyone can see the slide that I'm sharing. Is there a weird red line drawn on it?
Yes.
Anyone else? Okay, I don't know. I think someone
Yeah.
in the group might have accidentally annotated on top of
Let
it.
me try to help erase it.
And if not, I can just stop share and start again. Maybe that will be the best thing to do. Okay, I think that should be better now.
Okay,
Yeah.
perfect, Molly.
Lovely.
Thank
Okay,
you.
and as I mentioned, I'm just going to give a very quick intro and then hand over to Magda. So the title of my introduction is, what is the IUCN Green Status of Species and why should you get involved? So what is the green status of species? This used to be called the green list, but now we do call it the green status. And the green status is an official IUCN assessment of species recovery. So an assessment of our goal, what we want to achieve. And the green status of species was officially adopted by IUCN in 2021. And it is actually a part of the red list of threatened species, which is why we don't call it the green list, we call it the green status, because it's part of the red list and it complements what the red list does. So the red list tells us about the extinction risk of a species, but the green status adds to that. So the green status adds new metrics of species recovery to the red list, and also metrics that assess the impact of past and future conservation action. So I'm just going to give a very little bit of information about how that works. So when we think about what does the green status add? With the red list that we all know, we get a assessment of extinction risk. We get an extinction risk category. So on the screen, we have a species that's least concern, very low risk of extinction. But what new information can we learn if we engage with a green status assessment? So the first thing is something called a species recovery score. And this is a score that ranges from 0% to 100%, where 100% is a fully recovered species. And in this document on the screen, the IUCN Green Status of Species Standard, we provide a definition of full recovery. So we consider a species fully recovered if it is viable and ecologically functional in each part of its pre-impact range. And Magda is going to tell us a bit more about how all of this is measured. But for now, just to understand that the green status provides this definition of what is full recovery for a species. And if we have this definition, we can measure how close a species is to it, and we can set it as potentially a target that we might want to aim for. Just like the red list.
Green status of species.
Yes. Just like with the red list, the green status also uses categories. So we have the species recovery score from 0 to 100, where 100 is a fully recovered species. And then we can transform that score into a category. That's a bit easier to explain. So if we have a species that is farther away from recovery, we might put it in the category largely depleted, like we can see on the screen. So there are all these different categories from fully recovered to slightly depleted, moderately depleted, largely depleted, critically depleted, and then extinct. And so now with the green status, we have these categories that complement the extinction risk category that we're all familiar with. And the important thing to note is that the green status is not just the opposite of the red list. So a least concerned species is not necessarily going to be recovered. And a threatened species is not necessarily going to be far from recovery. So on this figure, on the bottom, we have our red list categories, so from low risk of extinction to high risk of extinction. And then on the vertical, we have our recovery categories from very far from recovery at critically depleted, and then fully recovered at the top. And what you can see is that for every combination of red and green, there are species that we categorize in these different categories. So you can have species that are both far from recovery and in danger of extinction, but you can have species that are not in danger of extinction, but also far from recovery and everywhere in between. So the green status is telling us new information that the red list is not telling us. And then finally, what is the third new thing that the green status can tell us? It is these conservation impact metrics, which Magda will tell us a bit more about. But basically, these are 4 different metrics that show the impact of conservation on moving a species towards recovery. So we have conservation legacy, which looks at the past impact of conservation. And then we have these forward-looking metrics, which Magda will explain in a bit more detail. But we can look at where do we expect conservation to take our species, and really argue that we should be continuing conservation for our species. So where are we now? So if you go on the Red List website, there are lots of species that now have a green status assessment as well. And you can see that their recovery category is now displayed next to the extinction risk category. As an example, we have our roti snake-necked turtle, which is one of those species that is both at high risk of extinction, but also far from recovery. And you can see it has a low species recovery score, very far from 100%. And so this information of these green status assessments is displayed alongside the red list. If we go down to the conservation impact metrics, so again, for that same species, the roti island snake-necked turtle, we can see that actually there hasn't been a lot of conservation for the species in the past. It occurs in protected areas, but even with that protection, the status of the species has continued to decline, but the species has a really high recovery potential. So with conservation, there is a lot of positive change we could make for the species. This is what the assessors found in their report. And again, Magda will explain a lot more about this. I'm just giving a very high level overview. So why should the specialist group use the green status of species? Well, we believe this will help gain a fuller picture of the conservation story for species in Indonesia. So it will help us understand how far are Indonesian species from being fully recovered to functional levels throughout their historic range. It will help us understand how impactful has past conservation been in Indonesia and in other parts of the range of Indonesian species. How do we expect conservation to affect a species status into the future? This can help incentivize and monitor action that will move species towards being more fully conserved. It will highlight if species are dependent on conservation, so help us argue that conservation actions should not stop for those species. And this will help ensure that funding and conservation action don't stop if a species is no longer listed in one of those really threatened categories, so critically endangered or endangered. Now, one of the reasons for our call today and why we started working with the Indonesian specialist group is that there is actually funding to create a green status index of species recovery. So a project that is underway to assess as many species in Indonesia as we can to create a green status of species recovery index. And this basically takes that average recovery score across species and allows us to track it over time, as you can see on the figure. So this is just a hypothetical example from a paper that we recently published explaining how a green status index would work. But the idea is that Indonesia would be one of the first countries to have this index for its focal species, which would be really, really exciting. And it's also really exciting because the green status index is an indicator for the global biodiversity framework under the Convention for Biological Diversity. So it is a indicator for Target 4, and Target 4 is all about how do we measure halting extinctions and achieving recovery. And then it's also an indicator for Goal B, which is all about maintaining and restoring ecosystem function. And so Magda will talk a little bit more about ecosystem function in her portion of the talk. I realized that was a lot. It was very quick, but hopefully I've intrigued you. I've got you interested to hear more. And we're going to save questions until the end. So I will pass over to Magda now to give some more details about the things that I've just introduced. So thank you very much to all of you.
Thank you, Molly. Very good presentation and very quick. To be honest, I already have some question, but like you said, like you will give, we will put the question and answer like at the end. So yeah, we will welcome Sigen for the next speaker. Sigen, please, the place is yours.
Hello, thank you very much. So I will just share my screen. Can everybody see that now? Just going to, yeah, all good?
Yeah, cool. You can see it.
Perfect. Okay, so as has sort of already been mentioned, my name is Magdalena, or Magda for short, and I work in the Red List unit in the UK, helping to publish green status assessments. So while Molly is kind of the strategic mastermind coordinating the projects, I'm doing the day-to-day work of supporting, reviewing, editing, publishing the actual green status assessments. So in my presentation, I'm going to reiterate the concepts that Molly covered and add some extra important details. So first, we're going to do an overview of the green status, just basic concepts and also the broad steps of the assessment process. Then I'm going to move on to some important clarifications just to address some common misconceptions about the green status. And then I'm going to talk very briefly on the Green Status Index and the work that we have planned with Indonesia, just to put this all in the context of this specific project and species recovery in Indonesia. And then we'll have time at the end for some questions and answers. So first of all, an overview of the green status. I'm going to start by posing a question that conservationists have posed for decades. What does it mean to successfully conserve a species? Is it when a species is least concern, like the grey whale, even if it exists in a depleted state compared to pre-commercial whaling levels? Is it when we've preserved it in a zoo, like the extinct in the wild Guam kingfisher, or deposited it in a seed bank? This isn't a simple question at all, but the green status offers an answer, which I'm going to explain in this presentation. Let's start by looking at the Red List, which, as no doubt you all know, is a measure of extinction risk. Since the Red List was created about 60 years ago, it's been the main way that we measure conservation progress, with a move from one of these higher risk categories to one of these lower risk categories being viewed as a hallmark of conservation success. But the Red List only measures extinction risk, which is one aspect of a species conservation status. And we conservationists need to ask ourselves, is it enough just to avoid extinction? Let's look for a second at a spectrum of species recovery relative to a pre-impact state. And by pre-impact, I mean that the species is fully ecologically functional and at a low risk of extinction throughout its historical range. Now, a species that is extinct on the Red List is obviously always going to correspond to 0% recovered. But at the other end of the spectrum, this relationship is a lot less clear. A species might be least concern on the Red List because it's naturally very widespread and hasn't declined recently, but it could still be significantly depleted relative to this historical benchmark. And this is really important information for us to know and that the Red List doesn't capture. And it's important because if a species isn't fully recovered, then it's not going to be performing its ecological functions at a baseline level, which will propel the deterioration and even collapse of those ecosystems where it's not fully functional. So just because a species is least concern doesn't necessarily mean conservationist work is done. And in a nutshell, that is the gap that the green status is here to fill. And that leads us nicely onto the two objectives of the green status, which Molly did briefly touch on. First, to provide a standardised framework for measuring species recovery. And second, to assess the impact of and incentivise conservation action towards a state of full recovery. So let's start by having a look at this first objective. Of course, in order to measure recovery, we first have to define recovery. And Molly has already presented you with this definition. The green status defines a fully recovered species as a species that is viable and ecologically functional in each part of its indigenous range. So it splits the concept of recovery into these three elements: viability, ecological functionality, and spatial representation. And a species that meets all these three criteria would be considered 100% fully recovered. But for species that don't fully meet these criteria, which is in fact most species in the world, they'd fall somewhere else on this spectrum. So let's say, for example, we have a species that is 50%, 56% of the way to being fully recovered. We'd call this percentage score the green score, or the species recovery score. And in order to make that continuous score a little bit easier to communicate, we divide it into species recovery categories. And these range from fully recovered through slightly depleted, moderately depleted, largely depleted, and critically depleted to extinct in the wild, down at 0%, same as the red list category. So this species with a hypothetical score of 56% would fall under the category moderately depleted. But how exactly do we calculate this species recovery score? There are 4 basic steps. First, we define the species indigenous range. Second, we divide the range into spatial units. Third, we assess the state of the species in each spatial unit. And then fourth, we use this data to calculate the green score, that percentage recovery score. Let's look at the first step, which is defining the species indigenous range. You've heard this term indigenous range a few times now, and maybe you're wondering what it means. A species indigenous range is its current range plus its range prior to major human impacts. And when we talk about major human impacts, we're focusing on impacts in modern history, so post 1500. And that's not to say that there weren't major human impacts before 1500, it's just balancing the need to avoid shifting baselines with the need to make sure that our recovery benchmarks are relevant to a modern landscape. So looking at this hypothetical species here, you can see that the indigenous range is mapped and it comprises the current range and the former range prior to major human impacts in modern history. The next step is to divide the indigenous range into spatial units. So for our hypothetical species, this might be what those spatial units look like. The basis for dividing spatial units is species specific, and it can be informed by a number of factors, but some of these include biology, so maybe you divide your spatial units by subspecies or subpopulations or evolutionarily significant units. Many other biological units as well. Alternatively, you can base your spatial units on ecology, for example, habitats or ecoregions. You can even use threats or conservation-based delineation methods. For example, maybe you'll divide your units based on conservation management units. And there are other factors that you can consider too. You'll learn about this more if you decide to continue with the full course. Or you can use a combination of different factors. The reason that we divide the range into spatial units is to capture spatial variation in the species status, which is something that the red list alone doesn't do. And it also helps us to recognise local conservation impacts. So where are things working and how can we emulate these successes elsewhere? And so the green status, because of the spatial units, is a spatially explicit assessment and that helps to make sure that the spatial representation aspects of species recovery is captured. So here is just an example of how spatial units were defined for the leatherback turtle. So in this case, the basis for spatial unit delineation was global subpopulations, and the species has 7 global subpopulations, so 7 different spatial units. Okay, the next step is to assess the status of the species in each of the spatial units. So you can assess the state of the spatial units as one of 4 state categories, which from worst to best are absent, present, viable, and functional. You assess a spatial unit as absent if within that spatial unit the species is extinct in the wild. The spatial unit is present if the species is present there but threatened according to red list criteria. The spatial unit will be viable if the species is present but the population within that spatial unit is not threatened. And then it will be functional if the species is present, not threatened, and carrying out its full range of ecological roles, interactions, and functions. So looking at this hypothetical species, the species would be assessed as absent in 6 of its spatial units, and then maybe viable in this one. And this step of the assessment process captures those other 2 elements of species recovery, viability and functionality. The final step is to use this data to calculate the green score. So essentially, each of those 4 state categories, absent, present, viable, and functional, has a weighting attached to it. And we combine the weightings of all the different spatial units to give the overall species recovery score, which is expressed as a percentage. And I won't go into details about the calculation right now, but again, if you choose to continue with the course, you'll find out all those details. But essentially, if every single spatial unit is assessed as absent, the score would be 0%, whereas if every single spatial unit is assessed as functional, the score would be 100%. And in this hypothetical example, the species recovery score would come out as 10%. So it rightly reflects that the species is a long way to being fully recovered. And then putting it into a category, this species with a 10% score would be classified as critically depleted. And these categories are really useful because they provide us with a standardized language for talking about this recovery depletion aspect of a species conservation status, which until the green status has been largely overlooked. Okay, so we've covered the first objective of the green status. So now let's have a look at the second, which is to assess the impact of and incentivize conservation action. Now this objective has 4 kind of sub-objectives. First, to recognize conservation achievements. Second, to highlight species whose current status depends on continued conservation. Third, to forecast the expected impact of planned conservation. And fourth, to elevate levels of ambition for long-term recovery. So how does the green status fulfill this second objective? I've already discussed how we calculate the green score or species recovery score for the species at, in the present day at the current point in time. But we don't need to stop there. We can use a combination of modelling and inference to estimate the score at different past and future points in time. So what was the score in 1950 and how have things changed since then? What do we expect the score to be in 10 years' time if all planned conservation goes ahead? And what score can we aspire to in 100 years' time if we do all the conservation that we possibly can and the only barriers are the species biological limits and a lack of available land? So we now have these 4 different green scores estimated for different scenarios at different points in time. But we still don't stop there. We use counterfactual reasoning to estimate what the state of the species would be without conservation. So what would the green score for the species be today if there had never been any conservation? And what would the score be in 10 years' time if all conservation were to stop now? So altogether, we have 6 different green scores estimated for different scenarios with and without conservation. Now, we can evaluate conservation impacts by looking at how the different scenarios, how the scores in the different scenarios differ. So the difference between the current score and the current without conservation score tells us the conservation legacy. In other words, the impact that conservation has had so far. The difference between the current score and the future without conservation score tells us the conservation dependence of the species because it reflects the future declines that we expect to prevent by continuing conservation. The difference between the current score and the future with conservation score tells us the conservation gains that we expect in the next decade. And then finally, the difference between the current score and the long-term aspiration tell us the recovery potential for the species, the maximum amount of recovery that we can expect to achieve with maximal conservation. So altogether, based on these different green scores for these different scenarios, we have 4 conservation impact metrics. And each one of these metrics fulfills one of the 4 sub-objectives that I showed on the previous slide. So conservation legacy recognises conservation achievements so far. Conservation dependence highlights species dependent on continued conservation. Conservation gain forecasts the expected impact of planned conservation. And recovery potential elevates levels of ambition for long-term recovery. And just like with the species recovery score, with these conservation impact metrics, we assign a category based on the percentage score. And these categories can be high, medium, low, or 0, reflecting high, medium, low, or 0 conservation impacts. It can also theoretically be negative if conservation has actually had a negative impact on the species, which we'd hope wouldn't be the case. And then the category indeterminate can be assigned if uncertainty is very high. So just to really illustrate the value of these conservation impact metrics, I'm going to take you through a few examples, starting with the mountain chicken, which is a frog, despite the name mountain chicken, from the Caribbean. So we're just looking at conservation legacy with this species. So you can see from the red list that the species is critically endangered, and it has been critically endangered since 2004. So for 20 years, it's been at the highest risk of extinction as a result of pervasive threats. Now, people might look at this and say, well, it's been 20 years, we've been doing all this conservation, but it's stayed critically endangered. So clearly the conservation is having no impact. Why are we bothering? But the green status tells us that conservation legacy for this species is high, because without conservation actions like a hunting ban and a ban on importing invasive predators to the species range, it's very likely that the species would be extinct today. So even though conservation action hasn't improved the red list status, it has prevented extinction, which is a huge impact that the red list alone doesn't capture, but the green status does. Next, for conservation gain, let's take a look at the Philippine crocodile. Again, this is a critically endangered species that's declined by 82% over the past 3 generations. And you can see from this range map that it's become locally extinct in the majority of its historical range. And again, people might look at this and say, well, you know, conservation doesn't seem to have improved the status very much. Maybe it's a lost cause. But the green status tells us that conservation gain for this species is high. And that's because right now there are loads of people working really hard in the background, planning reintroductions to some of these red parts of the historical range. And as a result of these reintroductions, the number of occupied spatial units is expected to double over the next 10 years. So just because conservation impacts haven't come to fruition yet doesn't mean we should give up, because success could be right around the corner. And then for conservation dependence, let's have a look at the giant panda. So this assessment isn't actually published yet, it's underway. So this is a sneak preview. But just to give some background, the species was downlisted from endangered to vulnerable in 2016, which is of course a fantastic success story. But actually a lot of panda conservationists were really concerned about this, because it doesn't reflect the fact that the reason for this downlisting is intensive conservation action, things like supplementary feeding and breeding programs. So the species is highly dependent on continued conservation. If we were to stop those actions, it would rapidly backslide to endangered. And yeah, the red list on its own doesn't reflect this, but the green status will. We're expecting that conservation dependence for this species will be high, which will provide strong grounds for continued funding of conservation action. Okay, so I've now covered both of the objectives of the green status, and hopefully I've convinced you of their value. So let's move on to some important clarifications. First of all, hopefully you realise this by now, the green status is not a list of recovered species. In the same way that a species can be least concern on the red list, a species can also be critically depleted on the green status. They're completely different spectrums, and a species can be at either end of both spectrums. It's still possible to do a green status assessment if a species is not recovering and if there is no conservation action. If there hasn't been any past conservation and there's no future conservation planned, the conservation impact metrics will all come out as 0. And in some cases, actually, these are the most important assessments to do, because they highlight urgently where conservation is needed. You might think that because you have to assess the state of the species in lots of different spatial units, you'll need really high resolution data. But that's not true. And it's because the state categories absent, present, viable, and functional are actually very broad. So if you have an expert that is familiar with the species and the geographical region that you're looking at, it's highly likely that they're going to be able to gauge which of these broad categories the population will fall into. But even if they can't, it's okay, because the assessment factors in uncertainty. So this is just the view that you get on the website. Here's the name of a spatial unit, and here are the different scenarios that the spatial unit is assessed under. So you can see that, for example, for the former state, a best estimate of viable is given. But the assessor clearly wasn't sure if this was true, and they gave a lower bound of present and an upper bound of functional. So you give a best estimate, a minimum, and a maximum for each spatial unit scenario, and then this is all factored into the calculation of the final score. So when the species recovery score is displayed on the website, uncertainty is there in brackets. And as I've mentioned before, if that uncertainty is very high, the species is given an indeterminate categorization. The green status is not just the inverse of the red list. Again, hopefully you realise this by now. This was actually tested for the proof of concept paper by Molly et al. In 2021. So here you can see the red list category plotted along the x-axis, and then the green status species recovery score along the y-axis. And there is a correlation. So species with a worse red list category tended to have a lower species recovery score, as you can imagine. But actually, there's a lot of variation within that. So there's some species that are critically endangered on the red list, but actually only moderately depleted on the green status. And Molly already showed this figure, but it's essentially the same thing as this graph, just a little bit of a prettier presentation. You can see that for every red list category, there's a species coming in nearly every corresponding green status category. So we definitely get new information from the green status. And then also looking at how red list categories compare to the conservation impact metrics, there's barely even any correlation here. So we're definitely getting new information out of these as well. So now, just to put this all into context, I'm going to talk a little bit about the Green Status Index and how it relates to this project with Indonesia. An important part of local and global conservation initiatives is measuring progress towards biodiversity goals. And we have a number of indicators to help us do this, one of which is the Red List Index, which tracks trends in species red list status over time. So it looks at the average red list status for a group of species and how this changes. So for example, in this graph, you can see red list index plotted for a number of taxonomic groups. And you can see that for corals, the average red list status has worsened quite dramatically in recent years. For birds, the decline has been less dramatic. But to put this in a global context, the Red List Index is a headline indicator for tracking extinction and extinction risk under the Kunming-Montreal Global Biodiversity Framework. But the GBF doesn't just aim to halt extinction, it also aims to assure that the abundance of native wild species is increased to healthy and resilient levels. So it aims to promote recovery. And until recently, there's been no index or indicator to measure progress towards this GBF goal of recovery. And that is one of the reasons why the Green Status Index, or GSI for short, was developed. So it's analogous to the Red List Index in that it tracks trends over time for groups of species, except instead of tracking trends in red list status, it tracks trends in the Green Status Species Recovery Score. And this sort of proof of concept of the framework was published in 2025, and it's already been adopted as an indicator for tracking recovery under the Global Biodiversity Framework. Again, Molly already briefly mentioned this. Just to give you an idea of how the Green Status Index works, I'm going to return to this graph, which you've already seen many times in this presentation, except this time, instead of looking at the green score for one species, we're looking at the average green score for a group of species. And this may be a taxonomic group, or it may be a geographically based group. So if we complete green status assessments for all the species in the group, we can derive an average former state. So this error bar shows uncertainty, which I just mentioned how you calculate based on the upper and lower bounds. And of course, we can also get an average current state for that group of species. So already from a single batch of assessments that includes the current and former state of each species, we can see the average trend of that group of species from 1950 to now. But green status assessments also show the future with conservation, allowing you to predict the future trends of that group of species, and future without conservation, allowing you to predict a worst case scenario. And then we have this space of possibility between these best and worst case scenarios in which future change could take place. So if you carry out green status assessments for those groups of species at regular intervals, you can plot where within this space of possibility the actual sort of realized change takes place, and then get this trend over time. So that is essentially what the Green Status Index does. So now, putting it all into context, and just to tell you about the scope of this project, we have this Green Status Index framework that is fully developed but hasn't yet been piloted. So our plan is to assess multiple Indonesian species under the coordination of the Indonesia Species Specialist Group, and then index that group of species, allowing us to pilot the GSI framework while also taking the first step towards an Indonesian index of species recovery. So by participating, you'll have the support of the Green Status Task Force and the Indonesia Species Specialist Group to quantify recovery and conservation impact for your focal species through a green status assessment. And in doing so, you'll also help to map the national level trends through the indexing process. And this will ultimately contribute to the launch of this new global green status index. So yes, definitely get involved. Okay, so that's all from me. And now, what time is it? We have a little bit of time for question and answer.
Thank you, Magda. The presentation is ended like about 5 minutes earlier rather than planned, so it's good, which is like we gonna have longer time to question and answer. So yeah, I will open question and question session for the participant. It's okay to give the question in bahasa. I will try to translate. Kalau mau tanya, sorry, I will speak in bahasa. Kalau mau bertanya pakai bahasa Indonesia boleh. Nanti saya akan bantu untuk translate. Okay, there is a question from Rena. Rena Hernawati, please.
Yeah, thank you for the opportunity. There is that's a very good presentation, and I want to ask about if I found species that already declared as extinct in the wild. What assessment that I have to do? For example, if I get the recent distribution of the extinct species, should I prepare some assessment for the red list assessment or the green status? Thank you very much.
Thank you, Rena. So before I move to Magda or Molly to answer, I will just ensure that the species was already declared as extinct in the wild.
Yes, and there is no rearing effort from the species. Yeah, only.
Okay.
Thank you.
Okay, cool. Yeah, like Molly or Magda, like anybody, if like you want to answer. Time is yours, please.
Yeah, so I'll start off and then Molly can add if she wants to add anything. So in terms of should you do a red list or green status assessment, I'd say definitely both are valuable. The red list will highlight the fact that the species is extinct in the wild. But what the red list won't highlight is the future opportunities to maybe make it not extinct in the wild. So I think you said there's currently no conservation ongoing or planned. So it sounds like there's no plans yet to reintroduce the species to the wild. But in the green status, that long-term aspiration scenario could reflect a situation where you do the maximum amount of conservation over 100 years and then maybe reintroduce that species into the wild. And so it will give a projection of what could be achieved if we invest all that we can into the conservation of this species, providing a sort of optimistic, positive outlook that will spur people into action, hopefully.
Yeah. Okay, thank you. Is that pretty clear, Rena? Yeah, I think so. Okay, cool. Thank you. Is there any more question from another participant? Okay, I will like read. There is like one question from the main chat. Oh, there is a lot of question in the main chat. Sorry, I didn't see it. What is the focus taxa for the green list Indonesian species project? It's like one question from Pramana Yuda. It's like anybody want to answer it?
Yep, I can take this one, and Magda, you can add as well. So for the Green Status Indonesia project, we are looking at species that would be highlighted under Target 4 of the Global Biodiversity Framework. There's not an official definition under the GBF what these species are, but they are species that require direct conservation action for the recovery of those species. And so actually our working group is developing a species list for Indonesia that Celia and others have been involved with compiling. And so it would be looking across different taxa. So birds, plants, mammals, reptiles, amphibians, invertebrates, fungi. So it wouldn't be taxonomically focused, but it would be focused on species that require conservation action. And Celia or Magda could say more.
Yeah. Cool. Thank you so much. And then I will go to another. It's so many questions, like from D. Worabai. He gave so many questions, but it's like interesting. Before I read it one by one, I want to give my own question. So like, because it's like very important in Indonesia, we try to make our national red list assessment, but while waiting for that and while we have the process for that, we always like using the global assessment. And then some of us thought it wasn't really fit with the condition in Indonesia, so we are working on that. But like for the species that we have the data deficient, and then the data is like very limited, so we can't make a national assessment. It's gonna be a question mark, because like we gonna use the global red list status, but like based on the presentation, we need to consider about the indigenous spatial ecology, which is like it's gonna be like from global and then into a very locals, and then how to adjust from the all of the global red list status into a local one, because we consisted by many islands, and then maybe the situation of because I'm shark people, I'm shark person, maybe shark in Sumatra Island and then shark in Papua Island, the condition gonna be really different. And yeah, it's the stock also completely different. So how green status facilitate that? Is that gonna be a different green status area for the different area, or how to adjust on that system of the green list status?
Magda, would you like to talk about the spatial element? Or I'm happy to answer if you like.
So sorry, I'm just not 100% clear on what the question is. Is it discussing how you derive data for the different spatial units?
Yeah. If like because like sometimes we have like very data deficient information, so maybe like we have no data, so we have to consider about like global assessment, like global red list assessment. But in fact, maybe like in very local criteria, local condition gonna be different. So if we want to make that, we gonna consider that into based on population and based on spatial area, or just like in national green status list, like how to divide that into the green status list.
Yeah, okay. So when you're doing a green status assessment for, say, it's an Indonesian endemic species, you divide the range into spatial units, and then as part of the assessment, you assess the state in each spatial unit, as I kind of mentioned. And so the state of the species in the individual spatial unit is not constrained by the global status of the species. You're just considering how that individual population within that spatial unit is doing. So even if there's a national assessment that says the species is critically endangered, it might be the case that in that one spatial unit, it's actually fully functional and it's not depleted at all. So you're just assessing the state within that spatial unit, not taking into consideration, or mostly not taking into consideration, the sort of global context. Now, if you don't have the data to assess the state of the species in one or more spatial units, then that's when the uncertainty comes in. So I kind of briefly showed that when you're assessing the state of a spatial unit, you have the lower bound, the best estimate, and the upper bound. So if you really have no data and you have no idea if the species is locally extinct or fully functional in the spatial unit, you'd do the lower bound as absent, the upper bound as functional, and then the best estimate as something in between, whatever the experts deem is most likely. And if that is the case for a lot of the spatial units, the final score would come out as having very high uncertainty, and it would probably receive the category indeterminate. But it's still valuable because it highlights where more research is needed, and in particular, the green status highlights the individual areas in which more research is needed, not just, like the red list data deficient, we just generally need more research. And you might still get valuable data from the conservation impact metrics as well. So yeah, I'd say data deficiency is wouldn't prevent an assessment being carried out. We can work with it and still get a valuable assessment. I don't know if you have anything to add, Molly.
Yeah, no, that was really helpful. Just to say that thinking about the Indonesian context, you would probably be looking at the status of the species on different islands, for example, for your green status assessment. And so you could use local information where it exists. If it doesn't exist, as Magda said, there are ways to incorporate uncertainty. And this is a really big topic, and it's really hard to kind of wrap our heads around in just one session. So I would recommend, if you want to really understand this, engaging with the further training, because we'll spend time discussing this in a lot more detail.
Okay, cool. Thank you. Because that's my question, and that's also the first question of so many questions for Pak Warobai. So it's like, yeah, very interesting because like each island can have like each different, local conservation effort, and then maybe like different population status, and then different condition, and then yeah, we are a very big country with heaps of biodiversity, and then the condition can be really different. So yeah, that's thank you for the answer. So I will jump to the third question from Pak Warobai, and then I will read one by one for another question. Like, what is the challenge in assessing a species ecological functionally in the context of the green status? Because in case we don't have the former ecological function information, because the research just conducted in last 1 or 2 years, and then we haven't really got the information about 85 years ago, because like maybe we still busy with war, with colonialism or whatever. And yeah, that's the things, like maybe we didn't really have the former information, but like how to ensure the species is like ecological function.
Yeah, okay. So it's a whole individual step of the assessment where we evaluate what the functional state looks like for that individual species. So it's species specific. And, in some cases, maybe we do know what the fully functional state for that species looks like, and maybe there's a clear indicator, like the textbook example with the sea otter, where, it eats the urchins and then the kelp can grow. And so, if there's a kelp forest, then the sea otters are fully functional. But of course, for a lot of species, there isn't such a clean relationship and a clean indicator that we can defer to. So in a lot of cases, we use proxies. So for example, maybe there's some historical data on carrying capacity or density of the species before major human impacts, or maybe there's a part of the species range today where there's been fewer human impacts and it's still at what you'd expect the historical density to be, or round about that. And so you can use the population density in that area as a proxy for the functional states. There are sometimes cases even where there isn't data on proxies available. And in those rare cases, we can incorporate it into the assessment via the uncertainty mechanism that I just explained. So if you're not sure what the functional state looks like for the species, but you think a spatial unit might be functional, you could always put functional as the best estimate and viable as the lower bound, for example. Do you have anything to add, Molly?
Yeah. So the reason we wanted to include ecological functionality in this assessment was, it's something better than just viable, just persisting. So it's this aspirational element for species conservation. And honestly, in most places in the world, for most species, we don't have historical data about functionality. And so we often end up using those proxies that Magda mentioned. And there's different ways that you can do it. So as Magda said, maybe we do have an example of sort of the best conserved area for the species, and we can say, well, the characteristics of the species there are probably close to what used to be functional. You might have other types of data, so you might have a spectrum where you have one really degraded area, one less degraded area, one better area, one slightly better, and you can see how an indicator for that species improves as you go from less degraded to more degraded, and think, okay, if we kept this trend going, what would the sort of good state, the functional state for this species look like? So there's different ways that we can approach this question, but the the main idea is that we want to be not just aiming for a persisting species, but a thriving functional species.
Yeah.
So better than we currently have.
Thank you. Yeah, it's interesting because like in Indonesia, like we are in tropical, and then as so many research already mentioned that in tropical, the extinction rate is like higher compared with subtropical, but we also are really resilient because of the biodiversity. So maybe one species like depleted, but the ecological system still like keep going, but that's also, it doesn't mean like it's fine to let one species gone. And yeah, that's the things that it might be also difficult to check the ecological function here in Indonesia, especially in tropical area, especially in Indonesia, because of the diversity and the diversity and then the tropical aspect that like we really resilient with like every the things that happen in our nature. So yeah, it's gonna be interesting to be discussed for another training. I will jump to another question, last question from Pak Worobai. I will mention it, like how to, like there are a lot of questions in the chat group, but we still have 30 minutes, so I'm gonna read it one by one. So for the participant that gonna ask some question, please be patient, harap bersabar, karena there is a lot of question, and I know it's like such a exciting session. Okay, the question is like, how can the green status help secure the funding to support sustainable conservation effort?
I think this one's for Molly. Been involved in this a lot more.
Can you bring more money to us?
We will certainly try.
Yeah.
One of the reasons why the green status was developed was to incentivize conservation action and sustain conservation action. So by showing how conservation in the past has improved the species status and how it's expected to change in the future if we stop conservation or continue conservation, we think that these are really powerful tools and data that we can bring to funders to say, this is what you could get if you funded our work, or this is what we would lose if you stop funding our work. And so having those data, having it presented in a standardized way, having it part of such a recognized global tool as the Red List, I think really gives us a good argument to go to funders and say, this is what we need, this is what you would be getting for your money. And so this is the big hope that once we have these assessments published, they will be used to justify funding. And I will say that certain funding agencies in the US, for example, are asking applicants to their grants to use this type of framework, this green status thinking, and say, what would your conservation impact be in the future if we were to fund your program? And so there is some evidence that this approach can lead to funding, and we hope it is implemented more widely around the world.
Thank you. Any more additional comment from Magda?
No, that was perfect.
Okay.
Thank you, Molly.
Oh, cool. Thank you. Maybe that's all the question from Pak Worobai, and then all of the discussion already answered the question. Hopefully that's helped. And then maybe rather than like keep me reading the question, I will let Erlinda Kartika to ask the question. Time is yours.
Thank you very much. I'm Erlinda, working for Sumatran Tiger, based in Padang, Indonesia. I just have like it's really interesting, and I'm curious to attend more training in the future. But one concern about like if I understand correctly, what you mentioned is like we kind of like tend to what is called count on expert opinion matter. So it's like the data is I don't know, like quantitative, like mostly. So how do we kind of like make sure that the data is in good quality to make like the adjustment of green status is good? That's That's all. Thank you very much.
Yeah, so I guess when you're evaluating the state of the species within each spatial unit in order to calculate the green score and then recovery category, it does use quantitative thresholds, which I didn't show in that presentation, but which if you continue with the course, you'll learn more about. So yeah, those quantitative thresholds are used. So it is a sort of rigorous standardized process. Expert opinion can come in when we're looking at the counterfactuals. So sometimes there is, empirical data to indicate what the status of a spatial unit might be without conservation, but sometimes we rely on inference, logical inference, expert elicitation. So that's often where the sort of that's sort of how the quantitative thresholds and the expert inference interact primarily within the green status assessment process. Yeah, I guess Molly, I'm sure you'll have stuff to add.
Yeah, I mean that was great, but just a few other things is that just like with the red list assessment of extinction risk, with the green status, we're using the best information that we have available for the species. And so I think that's a really important reason why uncertainty plays a role in the green status assessment. So if we really have no idea and the experts can't justify a state with sufficient certainty, then we do have that uncertainty built in. And I will also say that people like Magda in the Red List unit in Cambridge review every assessment and they're questioning every assumption. So the assessors say the species is viable on this island. What is your evidence for that? Are we convinced? If we're not convinced, we're going to send it back to the assessors and ask for more justification. And if they can't provide it, then we have to increase the uncertainty. So there is a really rigorous process to check all of these assessments and make sure that the information being presented to the public and to policymakers is the best possible information.
Yeah, thank you. Like a bit additional, maybe a bit comment from me because I'm working a lot with assessment and then I'm working also in Indonesia. Sometimes the fact about the expert judgment, it can be really subjective and really depends on the funder and funding. It can be like really not inclusive because, if like we don't really have money, so we just like can invite it only 2 or 3 people and we cannot really invited, like the indigenous expert from the local community. So yeah, it can be like really misleading. So I think like that's a very good point for from Mbak Erlinda, like how to make ensure the qualitative and quantitative one is representative from the real evidence or real condition in Indonesia. Because like the IUCN people in Indonesia, we are like the last fence for the extinction between all of the pressure and then like habitat loss, politics condition and everything. So we really try to be as objective as we can, but like funding and everything sometimes it's like really limited. So sometimes it's like really hard to ensure the good data between qualitative and quantitative and then ensure it to assess the species. And even red list is already hard to us, and then like made a green status is like another next level, like another homework. But I think like that's the things that why we need this kind of workshop or information. So how important the green status is, like we got more homework, of course, not only red list assessment but also green status, and then how helpful it is because there is also like measure the conservation effort, which is like but like back to the point is like it's like really hard situation and then really rely on the funder and then the situation at the field.
Yeah, funding is always such an issue, isn't it? It's so hard to get all the people in the room that you need and have enough time to work on these things, which is why I think this project with the Indonesia Species Specialist Group is such a great opportunity because there is funding to bring people together for workshops, for training, including groups that maybe traditionally there wouldn't be funding to bring in. So I think that's a really good point for me as someone who's helping organize these workshops is, are we including all the right stakeholders? Are we bringing in indigenous representation? So that's very helpful for me. Thank you. But I think because there is funding for this effort, it could be a really great opportunity to get that expertise for these assessments and make sure that they're really strong. So I appreciate you flagging that.
Thank you. Is there any additional comment from Mbak Erlinda, or I can go to another question?
I think it's enough. I just want to highlight that I really like the like in the green status, they put like this, all the good effort of conservation, like good practices and all those things. It's kind of like make us more like in positive way looking at conservation. I think that's all. Thank you very much.
Thank you so much. And then like I also want to highlight like how our member in like very remote places in Indonesia, they also like work with a lot of indigenous people who really working so hard in conservation with the local their local wisdom on conservation. So yeah, if like you come and then you see like how wonderful it is, it's gonna be like really amazing to see. Okay, I'm gonna go to another question. Where when there is no conservation action has been taken place, can we still do a green status assessment?
Magda?
Yes, is the answer. So when we're looking at the conservation impact metrics in the assessment, we don't just take into account direct action that's taking place for the species, but also, you know, any conservation action that might have affected the species. So, for example, if there's a protected area that wasn't dedicated to that species, but it's helped the species, that would factor into the conservation impact metrics. But even if there's been no conservation at all, no direct or indirect conservation, we definitely still can do an assessment. And what will happen is that the conservation legacy and possibly conservation gain and dependence metrics, they might come out as 0 because there's no, you know, past ongoing or planned conservation. But still in that long-term aspiration scenario, that recovery potential metric, we can imagine what could be achieved with all the conservation we can possibly do. And hopefully through that incentivize actually starting to do some conservation for that species. So yes, the short answer is yes, we can definitely still do assessments for species with no direct conservation. And in fact, it's strongly recommended to do assessments for those species in order to incentivize conservation.
Okay, cool. And then go to the second question of the first of the people who question it. How can we distinguish the green status resulted from conservation intervention versus natural recovery?
Yes, this is a really great question because sometimes there are changes in the environment or in sort of global politics that have a positive impact on the species that are entirely separate to the conservation actions we are taking. And the way that we deal with this in the green status assessment framework is we have specific definitions for what counts as conservation in our framework. And so you might see that the species recovery score is increasing over time. And then the way you would account for how much conservation has influenced that is you would look at, well, as Magda mentioned, the counterfactual. So what would the score be if no conservation actions had taken place? And so our conservation actions are very clearly defined. They have to be actions that are for species recovery or prevention of extinction. And we might see that actually no conservation actions have been taken, but the species score is improving because of these other factors. And so it's always a good thing to see that the species recovery score is improving, but with or without conservation. But by carefully defining what's included and assessed as conservation, we can tell what the actual contribution of conservation has been to that recovery.
Cool, thank you. Is that clear for the YK, Mr. or Miss YK? Maybe if like you still have another question, you can put it in the chat box. And then I'll go to sit at SPAS PhD. What's the role do spatial unit weight and functional weight play in SRS calculation? And what criteria used to decide number of boundaries of spatial unit of for an assessment?
Magda?
Okay, yeah, so I'll start on this one and then maybe Molly can add some stuff. So in terms of how the weightings of the spatial units combine into the overall score, so I mentioned that you can assess a spatial unit as absent, present, viable, or functional. And essentially each of these four state categories has a weighting attached to it. So absent is 0, present is 3 or 0.3, viable is 6, and then functional is 9. So essentially what you do is you add up the weightings of all the different spatial units and then divide that by what the number would be if all the spatial units were rated as functional, and then convert that to a percentage. So yeah, I mean, I guess that's sort of me explaining the calculation. It's probably hard to envision until you actually see it on paper, which, yeah, if you decide to continue the course, you will see how that calculation works on paper. It probably seems very abstract right now. And in terms of what criteria are used to define the spatial units, yeah, again, it's species specific. So it's what are the most biologically and conservation relevant spatial units for that species. In the case of Indonesia, islands might be a good basis for spatial units. Maybe islands combined with another factor, like if there's a barrier between two subpopulations on an individual island, maybe that would be a basis for defining spatial units. But yeah, it's just important to ensure that the spatial units are biologically relevant and relevant to conservation management for the species, and also that they cover the entirety of the species' indigenous range and not just the current range. So when you divide the spatial units, you're looking at the species in the context of its historical state, its benchmark state, not just what it is today. We do recommend limiting the number of spatial units. So we say, you know, aim for no more than 20, although it's not a hard cutoff, but aim for no more than 20 because otherwise you'll considerably increase the complexity of the assessment and also the time taken to do it. So yeah, I hope that answers the question. Do you have anything to add, Molly?
No, I think that is a good overview. And I think this is both of these questions are such big topics that we can't fully explain today. So I would encourage people to engage with the further training and stick around for those conversations.
Yeah, thank you. Another question is there any research paper or journal about the key indicator of the green status and then how to calculate all of the information? I think like I saw that, but you can ensure that and then maybe send that to us, and then we can distribute the paper maybe or the booklet or yeah.
Yes, what I can do now is I will put some key links to papers in the chat so everyone can have them, and then I'll send the same links around to the organizers to share.
It's
Okay,
worth
cool.
Oh, sorry. Yeah, I was just going to say it's worth mentioning that it's really valuable and useful to learn how all the sort of individual calculations work, but when you come to do the actual assessment, the sort of calculation of the species recovery score is done automatically based on your assessment of the state of the species in each spatial unit. So it's interesting and valuable to see what that calculation is, but you don't necessarily need to know it off by heart.
Exactly.
Okay, cool. And then another question is that green status applicable for multi-subspecies? For example, one species, it can have subspecies in the small island. I think that's related with the spatial thing, but yeah, you can answer it like any of you, Magda or Molly. Yeah, so if one species has multiple subspecies, I guess there's sort of two angles to this question. So first, if you're doing an assessment at the level of the species, you could define the spatial units based on the subspecies. And so by doing that, you're capturing the variation in the status between the different subspecies to derive this overall species recovery scoring category for the species as a whole. Another thing that we can do is to carry out a green status assessment at the level of the subspecies. So in this case, you're doing an assessment for just an individual subspecies and then the other subspecies separately.
and then you'll derive a species recovery score and category and conservation impact metrics for that subspecies, and you're capturing spatial variation within that subspecies. So yeah, in short, you can do a global assessment and capture variation between subspecies, or you can do a subspecies level assessment and capture variation within the subspecies. Yeah, is there anything to add, Molly?
Yeah, just looking at the question, is it, is the green status assessment applicable or more applicable to species with multiple subspecies? I would say it makes it more straightforward if there are subspecies, but you can do this assessment whether or not there are identified subspecies.
Okay, then another question. I think it's gonna be last one. So if like anybody's want to give question, we still have another 8 minutes, but I will read this question. I think it's connected with Erlinda question, like mostly it's like about quantitative data, because the problem in Indonesia is like we have no actual data for population. Can we create qualitative data, like as many for population average, or yeah, just like and a few, like less than 50% of the population. So yeah.
Yeah, so when we're assessing the state of each spatial unit to get that overall species recovery score, you don't necessarily need to have the exact number of species in the population. Having knowing sort of a range, so maybe you don't know the exact number of species, but you're pretty sure it's something between 100 and 800. Having that range is enough to be able to assess the state of the species in that spatial unit. And actually, there are some criteria for which you don't need to know the population size at all. Yeah, again, we can't get into all this right now. We don't have enough time to give the details of the criteria, but you might have other data, for example, on how much the habitat has declined in recent years within that spatial unit. And you can actually use that to assign the state of a spatial unit. So you definitely don't need to have population size data for all the spatial units. You can have ranges of population sizes, or you can even have other data related to habitat threats, so on and so forth. So a lack of sort of hard quantitative data is not a worry for this process. If yeah, you have anything to add, Molly?
Yeah, I think most of us don't know exactly how many individuals of a species there are in a particular area, but most of us as, conservation scientists and biologists could say, well, I'm pretty sure there's more than 100, or I'm pretty sure there's more than 1,000. And so we have evidence for that. And so if you can make those sort of judgments, you can do this assessment.
Yeah. Cool. Any other question? Yeah, because like some of the participants remind me to read all of the question and answer instead of expressing my own opinion, because it's like very interesting. So sorry if like I put a lot of my opinion here, but like, yeah, maybe like any other question from the participant. We still have another 5 minutes, because yeah, it's like very rare and honorable opportunity. From some participant that maybe already did some red list and then like interested to make it as a green list, a green status, I mean. Lovely. Okay, maybe I will read some of the key points for the last 5 minutes from all of the question and answer. It's before I bring it back to the Celia and the IUCN, Indonesian IUCN friend. Again, thanks Magda and Molly, and then thanks all of the participants. It's like very an honorable moment for us for having both of you to explain about the green status. And then we got it that green status is not only the opposite or the reverse point of the red list, but also to appreciate and then understand one more new passage. Oh, thank you. Okay. And then like about conservation effort and then how monitoring can be done. So it's like interesting for us, and then especially with all of the research, science, and then conservation effort that we like being conducted in Indonesia, which is like from Sumatra until Papua, with all of the biodiversity and everything. So it's such a big optimism step for us as Indonesian and then as a IUCN member. And then like, of course, hopefully this effort can also support some of the funding for us, especially for conservation effort to support the biodiversity in Indonesia as the one of the hotspot for the biodiversity in terrestrial and marine nature, marine ecosystem. And then yeah, thank you all of the question. Maybe Celia also, maybe I will bring it back to Celia for closing. Thank you.
Yeah, thank you, Banaya, for your time and effort in moderating our session today. And also, thanks a lot to Molly and Magda, both of you who have shared your knowledge about this new tool. I think it's been very interesting, and hopefully it can give us the basic foundation to do the green status of species assessment in Indonesia. And maybe the last reminder from me, for you guys who have registered for the IDSSG training of green status, don't forget to register the account on the link that we have put on the guideline of this training, so that you can start the training for the module 1 and 2. And for the next Thursday, we can start for the discussion session for those model. Maybe that's a last thing from me. Thank you, everyone. Thank you, Molly, Magda, and Babenaya. See you again.
Thank you, everyone. Have a good weekend.
Thank you.
Have a good weekend and have a great day for Molly and Magda.
Thank you.
See you.
Thank you.
Hope to see many of you again for the training. Bye.
Yes.
Yeah.
See you.